So what we have here is we have this concrete seawall that has a density of 150 pounds per square or per cubic foot. And what we need to do is we need to find the weight of this wall. So we're going to do that by finding first the volume using our Pappus and Guldinus equation. And if you want a video explaining a little bit more about those equations, you can click on this video link. And I've also got a little bit of the stuff written out down in the description about these equations. And so if you find this video helpful, hit that like button and please subscribe. So what we might want to first do is write out this this area that is being revolved around an axis to be able to give us this concrete wall. So it's being revolved about some axis right here, and the radius to this corner of it is 60 feet. And so we have this area, and we can split it up into its components because that's going to be the easiest way to do this. So we have our volume equation dealing with the composite bodies. So we have our two composite bodies. We have our rectangle and our right triangle, and we are going to label them A and B, and we are also going to draw their centroids. In this rectangle, it's going to be just right in the middle. In this right triangle, it's going to be 1/3 along this edge away from this right corner, and likewise 1/3 along this edge away from this corner. And the reason why we're doing that is because we need to find R tilde and A. A is the area of each component of each part of our composite body, and R tilde is the perpendicular distance between our axis of rotation and our centroid. So to find that distance, we're going to label them over here. So for A, we're going to find our R tilde, and that's going to be 60 feet plus 2/3 of the length of the base of this triangle. And the length is 15 minus 8, which is 7. So 2/3 times 7 plus 60 is 64.67 feet. And then we need to find the area of each one of these. The area of our right triangle is going to be the base times the height divided by 2. And so 7 times by 30 divided by 2 is 105 square feet. And then we're going to do the same for B. So B, its perpendicular distance between the axis of rotation and its centroid is going to be 60 feet plus 7 plus half of this distance, which is 4, because the full distance is 8. So that comes out to be 71 feet, and then its area is 8 times by 30, which is 240 feet, or square feet. So we have all this information for R tilde and A. We need theta to be in radians because, well, theta is the angle of rotation measured in radians, and a lot of the times that's going to be 2 pi because we revolve it all the way around a full 360 degrees, but in this case it's not. So theta is 50 degrees, and to get that into radians you multiply this by pi over 180 degrees, and that comes out to be 0.873 radians. So now we have all of our information we need to find the volume. So that is 0.873 multiplied by the sum of this multiplied by this and this multiplied by this, and that's what I'm going to write right here. And so we plug this into our calculator and we get that the volume of this is 20,804 cubic feet. So there's our volume. Now we need to multiply that by our density to find the weight of this entire concrete wall. And that is going to be W for our weight. 20,804 multiplied by 150 is 3,120,584 pounds. So our concrete wall weighs a little bit more than 3 million pounds, and that's pretty heavy, but that's to be expected, I guess. So there's a pretty good example problem of using our Pappus and Guldinus equation to find the volume of an object created from an area being rotated around an axis. And I hope you found this helpful. If you did, hit that like button. If you have any questions or suggestions, leave them down in the comments and I'll reply to them. And I appreciate your feedback. I've got my website up and going, gostudentengineering.com. It's got all these videos on there, plus a little bit more extra that you'll find helpful, I'm sure. So checking that out helps me a lot. If you're new to this channel, my name is Preston Palmer with Student Engineering, and my goal is to help other engineering students like me better understand engineering. So if you found this video helpful, hit that like button and please subscribe.